Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is June 2017, Paper 1, Higher Tier. Now, with the new specification being new, Grade 9 to 1 past papers are like gold dust, and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback, and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. So this is AQA GCSE Mathematics Higher Tier Paper 1. It's the June series of exams, but you noticed it actually went out in May, a little bit earlier that year. So let's get on with question 1. Question 1. Simplify 2 to the power 5 times 2 to the power 3. So our laws of indices say we've got two numbers with the same base, which we have here, 2 and 2. We just simply add the indices. So we're going to add the 5 and the 3 together. That's going to give us 2 to the power of 5 plus 3, which is 2 to the power of 8. Question 2. Circle the reason why these triangles are congruent. Now we've got 4 different rules for congruency for triangles, and these are our 4 different answers we've got that we can ring here: side, 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 angle, and right angle, hypotenuse, side. So you can see here we do have a right angle in both, but what we don't have is the hypotenuse. Instead, we've been given those 32-degree angles that match up and the included side, so that one and that one. So we've got 2 angles and an included side, so our reason for congruency is this one here, ASA, and not that one there. Question 3. Which of these is a geometric progression? Circle your answer. So a GP is where you've got a common ratio between each term of the sequence, so they've been multiplied through by the same thing. So let's have a quick look at the differences. In this first sequence, the difference between each term is 2, so it's going up in even increments. This is an arithmetic progression, so this is not the one we want. This next sequence, 2, 3, 5, 8, 12, you'll notice that each term is the sum of the 2 previous ones. This is the Fibonacci sequence, or Fibonacci type sequence, so that's not the one we want either. Third sequence, 2 to 6, well, it's add 4, but another way of thinking about it is it's 3 times bigger than the one before. 6 times 3 is 18, 18 times 3 is 54, and 54 times 3 is 162. So this is going to be GP. The last sequence is also going up in 4s, so this is another arithmetic progression, so that's not the one we want either. It's this one here, 2, 6, 18, 54, 162. In question 4, we're given that the ratio of A to B is 4 to 3. Well, if that is the ratio, then A over B is going to be 4 over 3. Now, rearranging to make B the subject, I can cross multiply that B up there, the 4 down there, and the 3 over there. That's going to give me 3a over 4 is equal to b. So b is 3/4 of a. It's that one there. Question 5. Write 36 as a product of its prime factors. Give your answer in index form. Now, I like to do these as a factor tree. So starting off with 36 as my top number, I need to find a pair of numbers that multiply together to give me 36. 3 and 12 spring to mind. So 3 goes there, 12 goes there. 3 times 12 is 36. Now 3 is prime, so we can stop on 3. But 12 is not prime. I can think of two other numbers that multiply together to give me 12. Let's choose 4 and 3. Again, 3 is prime, so that's a stopping number. But 4 isn't. I can break that down into 2 and 2, which are both primes. So looking at all of our terminating branches, multiplying those together will give us our original number. So 2 times 2 times 3 times 3 is going to be equal to 36. Always worth double checking these. 2 times 2 is 4, times 3 is 12, times 3 is 36. Now it does actually ask us to do it in an index form here, so we just need to write that in powers rather than as a sequence of multiplication. So 2 times 2 is 2 squared. And 3 times 3 is 3 squared. So our answer is 2 squared times 3 squared. In question 6, we've been given a group frequency table showing the times it takes 10 people to complete a task. And we can see that it took one person between 0 and 20 minutes to complete a task. It took 6 people between 20 and 40 minutes. And it took 3 people between 40 and 60 minutes to complete the task. Now there's a series of questions underneath that we need to decide whether or not are true or false, depending on the information we've been given. So the mean could be less than 20 minutes. Now is that possible given the data that we've got in the table? Now with group frequency tables, you do lose a little bit of the accuracy because we don't know for sure what value that one person who completed the time in between 0 and 20 minutes took. I mean, it could have taken them 1 minute or it could have taken them 20 minutes. So, depending on where within those ranges these people actually lie, is it possible for these things to have happened? So, could the mean be less than 20 minutes? Now let's take this one person here who got a time between 0 and 20. The time needs to be strictly greater than 0, but we can use 0 as a boundary on this calculation nonetheless. So I'm going to assume that this one person took a time of 0 or as close to a 0 as it could get, so it's actually slightly bigger than 0. And the same, we'll take the lower bound of the other two. So let's assume these 6 people took just over 20 minutes and these 3 people took just over 40 minutes. Then multiplying those through, 1 times 0 is 0, 6 times 20 is 120, and 3 times 40 is 120. Gives you a total of 240 minutes. And if you divide that by 10, then that's going to give you a mean of 24. So the mean cannot be less than 20 minutes then, because if I take the smallest possible bounds, I only get a calculation of 24, so that's got to be false. The mean could be more than 40 minutes. Okay, let's do the same thing. At this time, let's assume then that it's the upper bound of those categories. So I'm going to have a time of 20, 40, and 60 for those 3 groups. So 1 times 20 is 20. 6 times 40 is 240, and 3 times 60 is 180. Now adding those up, 2180 is 200, and 240 is 440. Divide that by 10 is going to give you a mean of 44. So yes, it could be more than 40 minutes. That is true. The mean could be less than 40 minutes. Yeah, of course it could. we've said that we've shown that the mean has to lie somewhere between 240 and 24 and 44 now, haven't we? So it could easily be less than 40 minutes. Now, can the range be more than 40 minutes? Now, the range is the difference between the highest possible value and the lowest. So let's take the lowest possible value for time in the first category and the highest possible time there. That would give us a range of around about 60. So could the range be more than 40? Easily, yes it could. Could the range be less than 40 minutes? Okay, so let's assume that first person is at the upper bound then rather than the lower bound. So here at 20, and let's assume that all those three people are at the lower bound there of 40. Then the range of those would be 40 subtract 20, which would be 20. So could the range be less than 40 minutes? Yes, it could. And could the range be more than 60 minutes? Well, we said the range could be 60, but it can't be more than 60. That is definitely the upper boundary, so that is going to be false. Question 7. 3/5 of a number is 162. Work out the number. Okay, well, if 3/5 of our value x is 162, what is x? Well, so all we need to do here is cross multiply this 5 and this 3. So I'm going to get x. X is equal to 162 divided by 3 times by 5. Okay. Now, is 162 divisible by 3? Well, rules of divisibility are if you can add the digits together and that divides by 3, your original number divides by 3 as well. So 1 plus 6 plus 2 adds up to 9. 9 is divisible by 3, so we should be able to divide this too. So let's give that a go then. So 3's into 16. Go. Well, 3's into 162. 3's into 1 don't go. 3 into 16 goes 5 times. Remainder 1. And 3 into 12 goes 4 times. So that gives me 54. 54 times 5. And then 54 times 5 times by 5 is the same as times by 10 and halving. So 540 divided by 2 is 270. So my answer is 270. X kilometers per hour equals y miles per hour. Use 8 kilometers per hour equals 5 miles per hour to write a formula for y in terms of x. Okay, now here y is clearly proportional to x, which means y must be equal to some multiplier of x. Y equals kx. Now all we really need to do is find out what k is. And we can find k if we can find two values of y and x that go together. Now we've been given them here. So 8 kilometers per hour equals 5 miles per hour. So that 8 must be equivalent to the x and the 5 must be equivalent to the y. So when x equals 8, y equals 5 means that 5 must be equal to k times 8. Subbing those two values in, rearranging, that gives me a value of k equal to 5/8. So my complete formula for y and x should be y is equal to 5/8 of x. Question 9a, density equals mass over volume, and we're told that the mass of solid A is 6 times the mass of solid B, and the volume of solid A is 3 times the volume of solid B. So let's say that for solid B, let's say it has a mass of m and a volume of v. Then solid A then is going to be 6 times the mass of solid B, so that's going to have a mass of 6m, and it's going to have a volume 3 times that of volume B, so it's going to have a volume of 3V. So what is the density of B? So density for this one is going to be big M over V. And the density of our solid A is going to be a 6m over 3v. So simplifying that down, that's 2 lots of m over v. In other words, our solid A is going to have a density which is twice as big as solid B. So I'm going to say it is 2 times the density of solid B. Okay, in part B, we're given that average speed is equal to distance divided by time. If the distance is halved and the time is doubled, what happens to the average speed? Well, let's do the same trick as before. If we start off with a distance d and a time of t, then what happens then if we halve the distance? So now I've not got d, I've got a half of d, and I double the time. So half d over 2t. Okay, so basically I've got d over 2 divided by 2t. That's going to be equal to d over 4t. In other words, our average speed is going to be a quarter of what it was before, which is the same as dividing by 4. It's that one there. Question 10. Solve the simultaneous equations 2x plus y is equal to 18 and x minus y is equal to 6. Now you should have a few methods up your sleeve for solving simultaneous equations, either by elimination or substitution or graphically. Here, this particular pair of equations lends themselves really well to elimination. You can see I've got a plus y and a minus y, so I can eliminate y very easily by adding these two equations together. So what is 2x plus x? It's 3x. What is y plus negative y? They're going to cancel each other out. And what is 18 plus 6? It's 24. So I've got 3x is equal to 24. That means that x must be equal to 24 divided by 3, which is 8. X is 8. Okay, so then I can just substitute that back into one of my original equations. Let's take the first one. So 2 lots of 8 plus y is equal to 18. So 16 plus y is 18. That gives me y is equal to 2. Then doesn't 18 take away 6? So my two answers then are x is 8 and y is 2. Now it's always worth just double checking these. We used the first equation, 2x plus y is equal to 18, for our working out of y. So let's just double check both solutions in the second equation. So check. I've got x minus y equals 6. So if x is equal to 8 and y is equal to 2, does that equal 6? Yes, it does. So that's just a quick check that you should do in the exam to make sure that you've got the right answer. Question 11. Billy wants to buy these tickets for a show. 4 adult tickets costing £15 each and 2 child tickets costing £10 each. A 10% booking fee is added to the ticket price. 3% is then added for paying by credit card. Work out the total charge for these tickets when paying by credit card. Okay, so first off, how much is the total amount to be paid? So cost of tickets. It's going to be my 4 adult tickets at £15 each, plus my 2 child tickets at £10 each. 4 15s are 60, 2 10s are 20. Adding those together gives me 80. So the cost of the tickets is £80. Plus we need to put on the booking fee. Booking fee is going to be It's going to be 10% of that, so That's going to be £8, isn't it? Give me a total of 88. And then finally, I need to add 3% for paying by a credit card. Okay, so I've got £88. What's 3% of £88? So this is my credit card fee. So if I have £88, then 10% is £8.80, and 1% would be 88p. So 3% is going to be 3 lots of 88 pence. So what's that? 24, 240 and 3/8. 264. £2.64. So then the total amount payable then is going to be my £88 plus my £2.64. So total could be 88 plus £2.64, which is £90.64. Question 12. Here is a circle touching a square. The area of the square is 64 centimeters squared. Work out the area of the circle, given your answer in terms of pi. Okay, so if I know that the area of that square, so area of the square is equal to 64, then each length must be the root of that then, because area of a square is length squared, isn't it? So L is going to have to be 8, okay, which means it is 8 from there to there. Now the formula for a circle is pi r squared. Now 8 is going to be the diameter of my circle, so the radius is going to be half of that. It's going to be a radius of 4. So my area of my circle is going to be pi times 4 squared. In other words, it's going to be 16 pi. So 16 pi. Question 13. Write the number 6,005,200 in standard form. Okay, let's try and write it out as a number first off. So 6 million is 6 followed by 6 zeros. Well, 6,005,000, so that's going to be 005 200, like that. 6,005,200. Okay, now we've got it written as a number. Now we can try and write it in standard form. So we're just going to write all the digits. 6.0052. I can forget about the last two, so I'm not going to change it either way. So times what? 10 to the power of, well, if the decimal point starts here and we're going to end up 1, 2, 3, 4, 5, 6, we're going to move it 6 jumps to get it to there, aren't we? So that's times 10 to the power of 6. So my answer is 6.0052 times 10 to the 6. Question 14. Solve negative 3x is greater than 6. Now, inequalities normally work the same way as equations. So what you would do with an equation, you can normally do with an inequality, with one exception, and that is when you divide through by negative numbers. Now, there's two approaches to this. Either when you're working with inequalities, you avoid dividing by negative numbers and therefore avoid the problem, or you have to remember that when you do divide by a negative number, you're going to have to flip the sign. So two approaches. So approach 1 would be to keep things positive. So what I could do is I could start off by changing sides, changing signs for these two expressions, moving them on the other side of the inequality. That would give me minus 6 is greater than 3x, and then dividing both sides by 3 is going to give me minus 2 is greater than x, or x is less than minus 2. Okay, the other way of doing it is just thinking about it as when you divide by a negative number, you flip the sign. So I could have just gone for if I start with minus 3x is greater than 6, if I divide both sides by minus 3, then I need to remember to flip the sign over, so x is going to be less than minus 2. Okay, so either you remember with inequalities, don't divide by a negative number, just keeping everything positive, or you remember that if you divide by a negative number, you're going to have to flip the sign over like that. Either way, the answer is x is less than minus 2. Okay, question 15. 1/6, 1/7, 1/8, and 1/9 are 4 fractions. Yes, they are. How many of these fractions convert to a recurring decimal? Circle your answer. Okay, well, I know some of these straight off. I know that 1/8 is 0.125, so that one doesn't. I also remember that 1/9 is 0.111 reoccurring, so that one is 1. That one isn't 1. 1/6 is half of a third, and a third I know is 0.3333, so I'm pretty sure that 1/6 is also going to be a recurring decimal. It's actually 0.166666 or 1.6. Yeah, it's got recurring 6 there, isn't it? So that one does. That one's got recurring 1. 1/7. Now, you may or may not remember this, but it is actually a recurring decimal. I suppose in an exam, if you couldn't remember, you could actually try and divide it by long division and see what you got. But if you did do that, I'm sure you would work out pretty quickly that it does recur. I'm going with 3. Question 16. A fair spinner has 5 equal sections numbered 1 to 5. A fair 6-sided dice has 5 red faces and 1 green face. The spinner is spun. If a spinner shows an even number, the dice is thrown. Complete the tree diagram for the spinner and the dice. Okay, so the spinner is spun, and if it is even or odd, depends on the number of faces, which have got even and odd numbers. So I've got 1, 3, and 5, which are odd, and I've got 2 and 4, which are even. So I've got 2 out of 5, which are even. So my probability then of going that way is 2 out of 5, which makes my probability of odd being 3 out of 5. So if the spinner shows an even number, the dice is thrown. So the dice is either going to be, what was it, red or green? Red or green. Now there are 6 faces altogether, 5 of which are red, so the probability of getting red is going to be 5 over 6, and therefore the probability of getting green is going to be 1 over 6. Now, we don't do anything if the odd number is thrown, so that one just terminates there at the odd. So that is my completed diagram. Right, for 16b, work out the probability of getting an even number and the colour green. So we want the probability of even and green. Okay, so and means multiply really with these things, isn't it? So the probability of getting even is 2/5, and the probability of getting green is 1/6. So the probability of even and green is going to be those two things multiplied together. So 2/5 times 1/6, which is 2 out of 30, or 1/15. In question 17, we're given that A is the point 2 minus 5 and B is the point 4 minus 9. Show that the gradient of the straight line passing through A and B is minus 2. Now the gradient of a line is given by changing y divided by changing x, which in terms of the coordinates would be y2 minus y1 divided by x2 minus x1. Okay, so if this is x1, y1, and this is x2, y2, subbing those numbers into our formula. So I'm going to get minus 9 subtract negative 5 divided by 4 subtract 2. So just need to take care with these negative numbers. So I've got minus 9 take away negative 5. That's the same thing as adding. So negative 9 plus 5 is going to give me negative 4. And 4 subtract 2 is 2. So negative 4 over 2, which is the same thing as negative 2. So I've shown that the gradient of this straight line is minus 2. Job done. Now we're told that C is the point minus 301, 601. Does C lie on the straight line passing through A and B? You must show your working. Now we've already found what the gradient of this line is, so probably the easiest way to tackle this question is to work out the full equation of the line and then sub those points in and see if it's true. So I know that equation of the line is going to be of form y equals mx plus c, so y equals minus 2x plus c, where c is the y-intercept, and I've already got a pair of points that go together when x is 2, y is minus 5. So when x equals 2, y is minus 5, so I can use those to evaluate what c is. So minus 5 equals minus 2 lots of 2 plus c. So negative 5 equals negative 4 plus c. Oops, negative 5 equals negative 4 plus c. Give me a value of c of negative 5 plus 4, which is negative 1. So then our completed equation is going to be y equals minus 2x minus 1. Okay, so does our point minus 301, 601 lie on this line? We can work that out by subbing the values into our equation. So if y is 601 and x is 301, sorry, minus 301, take away 1, is that true? So is 601 equal to minus 2 lots of negative 301 is positive 602 subtract 1, and 602 take away 1 is 601. That is true. So therefore minus 301, 601 does lie on line. Question 18. Bottles of drink are for sale at 3 shops. The normal price of a bottle is the same at each shop. In shop A, you buy 1 bottle and you get 2 more bottles at half price. For shop B, you buy 2 bottles, you get 3 more bottles at half price. And for shop C, you get 30% off a bottle. What is the cheapest way of buying exactly 8 bottles? You can buy from more than one shop. You must show your working. Now, often confuses students when there's no given price and all the things are just relative to a non-given price. So sometimes it makes it easier to just make up a price. Let's say let 1 bottle equal £1, 1 nominal pound or 1 math dollar, I don't really care. And then we can work out the cost of things from that. So if I buy 1 bottle, I get 2 more bottles at half price. That means I'm going to get 3 bottles. I'm going to buy 1 bottle at full price, and I'm going to get 2 bottles at half price. So that's going to be 1 plus 50 plus £1 plus 50p plus 50p. So that's going to be £2 then, or 2 maths dollars, whatever it is we're using. In shop B, we buy 2 bottles and we get 3 more bottles at half price. So I'm buying 2 bottles at £1 each, so that's £2, and I'm going to get 3 more bottles at half price, so that would be 50, 50, 50, which adds up to 5 bottles costing £2 and £1.50 is £3.50 or 3.5 maths dollars. Shop C is 30% off a bottle, so that is 1 bottle is going to be 70p or math cents, I don't know, whatever it is the unit is. So I want to buy exactly 8 bottles. What's the cheapest way of doing that? It's usually a good idea to then work out what the equivalent price per bottle is for each of the deals that we've got here. So I can buy in Shop A, I can buy 3 bottles for £2, which is equivalent to 1 bottle costing £2 divided by 3, which is about it's about 67p, isn't it? Okay, so that's quite cheap. That's cheaper than Shop C, where 1 bottle is 70p. This other one here, where I get 5 bottles at £3.50. If I divide £3.50 by 5, then that's going to be equivalent to 1 bottle being about 70p as well, then, or being exactly 70p. So you can see that Shop A offers the best value. So they come in lots of 3. So I want to buy as many as I can from Shop A. So if I buy 2 lots of my 3 bottles, that's 6 bottles, then I can buy 2 extra from Shop C. So I'm going to buy 2. So we're going to be buying 6 bottles from Shop A, which is going to cost us £4 maths pounds, and I'm going to buy 2 bottles from Shop B. Oh, from Shop C, sorry, which is going to cost me £1.40, making a total of 8 bottles costing £5.40. With these sorts of questions, just need to make sure you're showing sufficient working. Here we've worked out the unit cost and of the various combinations, plus we've worked out the cheapest combination, so that should be sufficient for our 3 marks. Question 19. Here is some information about the marks for 60 students in a test. So we've got a group frequency table, and underneath it says, on the grid, draw a cumulative frequency graph. Okay, so cumulative frequency is upper class boundary against cumulative frequency. So upper class boundary is the highest value of each one, so it's these numbers here, isn't it? So I'm going to be plotting 50 against 9. I'm going to be plotting 60 against those two added together. 9 plus 16 is 25. I'm going to be plotting 70 against, well, 25 plus 20 is 45. I'm adding those together, aren't I? So my 25 plus my 20 gives me 45. And then I'm going to be plotting 80 against those, which is 45 plus 8, which is 53. And then finally, I'm going to be plotting 90 against 53 plus 7. It's going to be 60. Always good just to check that this number here is the same as the one up here. It is, so I'm confident I've added up my cumulative frequencies correctly. Now it's just a matter of plotting. There's one other point I can plot. I can plot the lowest class bound here against 0. So my first point is going to be 40, 0. 40, 0 is going to be that point. My next point then is 50 against 9 and 60 against 25. So 50 against 9 and 60 against 25. Next 2 points, 70 against 45 and 80 against 53. So 70 against 45 and 80 against 53. And then finally, I've got 90 at 60. Okay, let's just zoom out a bit so I can see the whole graph. So you normally get a distinctive S-shaped curve when you plot in cumulative frequency. Might be a little bit hard to see here, but it's more or less there. Let's just join those up with a straight line. So you want to be joining these up with a smooth, continuous curve passing through the center of each of your points. And kind of topping out at your top value up there. Okay. Question 19b asks, use your graph to estimate the lowest mark of the top 20% of students. Now there were 60 students altogether, so the top 20% then, 20% of 60, well 10% of 60 is 6, so 20% is going to be 12 students. So we're looking for the top 12 students. So on our cumulative frequency, if we're going to have 60 at the top and we take away 12, we get 48. So that is where I need to read across from on my graph. So cumulative frequency of 48. Let's get the ruler out. I'm going to read across from 48 till I get to my graph. When I get to my graph, I'm going to change direction and read down. So it's there, isn't it? So what's that on my graph? That is about 74 or 73 and a half. So I'm going to round that up to 74, I think. So use your graph to estimate the lowest mark of the top 20% of students. It's about 74. Question 20. Work out the diameter of a circle x squared plus y squared equals 64. Now, equations for circle through the origin are always the form x squared plus y squared equals r squared. So that means that r squared must be 64. Giving us a radius of 8, and if the radius is 8, then the diameter is going to be twice as big as that. It's going to be 16. Is that one there? 21a. The diagram shows rectangles A and B. Yes, it does. And underneath it says rectangle A can be mapped to rectangle B by a single transformation. Javid says the only single transformation is a reflection in the y-axis because the rectangles are on opposite sides of the y-axis. So is that the only way that you could move A onto B? Well, yeah, it could be a reflection, but it could be all sorts of other things as well. It could actually be an enlargement scale factor of 1 or minus 1, sorry, so the image forms on the opposite side of the center enlargement, so that would work. Or it could be a rotation. It could be a rotation about this point here. So it could either be an enlargement scale factor minus 1 through that point or a rotation through that point. Either way, you would get A onto B. So he is not correct. So either one of those is given. So it could be. So it could also be a rotation. Center. What was the center point? 0, 2.5 of 180 degrees. Don't have to give a direction when it's 180, or like I say, it could be an enlargement as well, but 1 is enough. Question 21b. This diagram shows triangles CDE and PQR. There they are. And we're told that CDE is mapped to PQR by combining two single transformations. The first is a rotation of 90 degrees anticlockwise about E. Describe the second transformation. Okay, so it's going to be some sort of enlargement or with a fractional scale factor after that. But before we can do or work out the details of where the center of enlargement is, we probably best need to find where that mid triangle is going to be, the one that's halfway between them. So let's carry out this first transformation. That's a 90 degrees anti-clockwise about E. 90 degrees anti-clockwise about E. We're starting with CDE, aren't we? So 90 degrees anti-clockwise about this point here. That means my triangle is going to be, well, the point D is going to end up here. So that's going to be D dash, and C is going to be down there. That's going to be C dash. So we're going to have a triangle here. Okay, and then it ends up there. So what sort of enlargement is that? Well, let's put array lines on. Okay, so joining those 2 points together, we're just matching pairs of points on the object and image together. We should find that they meet in one place, which they do. You can see that they're converging. Oops. On that point there. So that's going to be my center of enlargement, that point at -1, 0. Okay, so it's going to be an enlargement. It's going to be centered on -1, 0. Now what's the scale factor? Now you can see that this side here, the shorter side of my triangle, is 2 in the original image, in the original object, and in the image it's 4, so it's twice as big, but it's also on the opposite side of the center of enlargement, so it's going to be a negative enlargement. So it's going to be scale factor of -2. Question 22. PRT and QRS are similar triangles, and we're asked which of these is equivalent to QR over PR. Well, QR is QR, that's that line there, isn't it? And then PR is this line. So basically you're comparing two equivalent sides of two similar triangles. So sides are always going to be in the same ratio, so as long as you're going to match up the pairs of sides you're looking at, then they are going to have the same ratios as well. So let's have a look. So RS to ST. So remember that QR was the smaller one and PR was the larger one, wasn't it? So as long as we've got the smallest one on the top and the largest one on the bottom, and they're matching up, they should be good. So where's RS? RS is that one, RS to ST. Well, that isn't going to work because they aren't matching sides. ST is not a side of the triangle, so not RS to ST. What about QS to PT? Let's just get rid of those two. QS is that side to PT. Yeah, those two are matching. Small one to big one, so yes, that one is true. What about PT to QS? PT to QS, that would be big one over small one. That isn't going to be the same. And RT to RS. RT to RS. Again, that's big one over small one, so that one isn't going to work either. So it's just that first one, then QS to PT. Question 23. Here is a velocity time graph of a motorbike for 25 seconds. After how many seconds was the acceleration 0? Okay, well the acceleration is going to be the gradient of the velocity time graph, and the acceleration is 0 when the graph is flat. So you can see, where is it flat? it's going to be flat here at this point here, or more in particular right in the middle of there. So at that point there, look, it's flat. So reading down to the graph, reading down to the axes below, it's there, isn't it? Now that is, well, you can see I've got 10 divisions between 0 and 5, so each division must be a half, or 2 divisions, or 2 little squares is 1. So I make that 6 then. So after how many seconds was the acceleration 0? It's going to be after 6 seconds. And then we say, it says work out the distance travelled in the last 15 seconds. Now distance travelled is the area under a velocity time graph, and the last 15 seconds is, so 25 seconds less 15 is 10. So it's this section here. Right. Just sort my pen out. So from here down to here. Now you'll see that this section of the graph is a straight line. Can't seem to draw on there. Okay, that's it. So this section here we're looking for. Okay, so that's the section of the graph is a straight line. So the shape we've got is a trapezium. So the area of a trapezium is going to be the 2 parallel sides added together divided by 2 times the distance between them. So this is my A value here, isn't it? Which is of a height 22. So A is 22. This is my B line on the other side. That is at a height of, I make that 18. The distance between them is this distance. We said for the last 15 seconds. So it's that 15 there. So distance travelled is going to be a half A plus B times H, the formula for a trapezium, which was a half of 22 plus 18 times 15. Got those right? 22, 18, 15, yeah. So half of 22 plus 18. 22 plus 18 is 40 divided by 2. So half times 40 times 15. Half of 40 is 20. 20 15s are 300. So it's 300 meters. Question 24a. Work out the square root of 12 1/4 as an improper fraction. Okay, let's start off by expressing 12 1/4 as an improper fraction to start with. 12 times 4 is 48 plus 1 is 49, so that's 49 over 4, 49 quarters. Now luckily both of those are square numbers, so I can easily square root them. So 49 square rooted is 7 and 4 square rooted is 2, so it's 7 halves. That is an improper fraction, so I can move on. Work out the cube root of 16 as a power of 2. Okay. Well, the cube root of 16, what is 16 as a power of 2? 2, 4, 8, 16, that's 2 to the power of 4, isn't it? So I can rewrite that as the cube root of 2 to the power of 4. Okay, which is the same thing as 2 to the power of 4/3. So that's my answer, 2 to the power of 4/3. Question 25. In an office there are twice as many females as males. A quarter of the females wear glasses. 3/8 of the males wear glasses. 84 people in the office wear glasses. Work out the number of people in the office. Okay. Well, let's start with the first sentence. In an office there are twice as many females as males. So let's say that X is the number of males. Then the number of females is going to be twice as many as that, so that's going to be 2x. Okay, now we know that a quarter of the females wear glasses, so females with glasses then is going to be my 2x, number of females, divided by 4, which is the same thing as x over 2. And we're told that 3/8 of the males wear glasses, so males with glasses equals, well, there are x males and 3/8 of them wear glasses, so it's 3x over 8. And then we're told that 84 people in the office wear glasses. Now, the total number of people with glasses is going to be our females plus our males with glasses, aren't they? So our x over 2 females with glasses plus our 3x over 8 males with glasses is equal to 84 people with glasses. Okay, so what can we do with that? Well, if we get rid of the fractions by multiplying through by, we don't really want to multiply through by 8, it's too big. Well, let's do it anyway. So multiplying everything through by 8. So times 8 times 8 times 8. What's that going to give me? So 8x over 2 is 4x. So 4x, 8's cancel there, leaving me 3x is equal to 84 times 8. That's the bit I didn't want to do. So 8 8s are 64, so 80 times 8 is 640. 4 8s are 32, so 640 and 32 makes 672. So 4x plus 3x is 7x is equal to 672. So now we need to divide 7s into 672. How many times does that go? 7s and 6 don't go. 7 and 67 go 9 times. 9 7s are 63, so it's remainder 4. 7s into 42 go 6 times. So x must be 96. So now I should know the number of everything. Work out the number of people in the office. Okay, there are twice as many females as males, so we decided there were 96 males. So then altogether there are going to be 96 males and 2 lots of 96 females. So total in office is going to be 3x, which is 3 times 96, which is, what's that? 300s would be 300. Take away 3 12s, which is 288, I think. So a bit of long multiplication and division there, but we got there. 288. 26. Expand and simplify x minus 4 times 2x plus 3y all squared. Okay, well, let's start off by writing it out as 3 brackets rather than with the square sign in. So x minus 4 times 2x plus 3y times 2x plus 3y. Okay, now if you know your identities, you can probably do that a lot quicker, but let's just use FOIL for now. So what have I got then? So that equals to x minus 4 times 2x, which is 4x squared, 3y times 2x, which is going to be plus 6xy. 2x times 3y is going to be plus 6xy, and then finally I'm going to get plus 9y squared at the end. Okay, so just collecting that middle term up. So 4x squared plus 12xy plus 9y squared. I was talking earlier about identities. If you can remember that a plus b all squared equals a squared plus 2ab plus b squared, it makes multiplying out these things a little bit more easy. You can go straight from the given thing to that step in one go. But let's just carry on now. So now I need to multiply everything in my first bracket with everything in the second bracket. So x times 4x squared, x times 2xy, and x times 9y squared. Let's do that first. So that gives me 4x cubed plus 12x squared y plus 9xy squared. Now I'm going to multiply it by everything in the second bracket by my 4, minus 4 times that, minus 4 times that, minus 4 times that. So what am I going to get now? So minus 4 times 4x is minus 16x squared. Minus 4 times 12xy is going to be minus 48xy. And finally, negative 4 times 9y squared is going to give me negative 36y squared. None of those terms are alike, so can I simplify it? Can't see anything that's the same all the way through. I think that's it. Just 6 terms. So my final answer is 4. So my final answer is 4x cubed plus 12x squared y plus 9xy squared minus 16x squared minus 48xy minus 36y squared. Question 27. P is the point minus 1, 4. Okay, so that's minus 1, 4 on the circle, center origin. Work out the equation of the tangent to the circle at P. Give your answer in the form y equals mx plus c. Okay. Now to find the equation of a straight line we need 2 things, either 2 points, which we don't have, or 1 point on the line and the gradient. Now we've got a point on the line, but we don't have the gradient. So we're going to have to find out one of those bits of information from our diagram somehow. Now, in order to get that extra bit of information, we can use the fact that a radius of a circle is at 90 degrees to the tangent drawn at the point of contact. So my line OP is going to be perpendicular to my tangent. So if I can find the gradient of OP, then I can work out the gradient of the tangent. So let's find the gradient of OP first. So OP has obviously got the coordinate 0, 0 and minus 1, 4. So gradient of OP, which I'm going to call M1, is going to be my change in y, which is 4 subtract 0, divided by my change in x, which is going to be minus 1 subtract 0, which is 4 over minus 1, which is a negative 4. So my gradient of OP is negative 4. Now, my gradient of my tangent is perpendicular. I'm going to call it M2, so that's going to be minus 1 over M1, isn't it, for perpendicular lines? In other words, it's going to be negative 1 over negative 4, which is 1/4. So my gradient is going to be 1/4. So the equation of tangent is of the form y equals 1/4 of x plus c, where c is the y-intercept. Now we know that the line passes through the given point, which had coordinates minus 1, 4. So if we sub those two into the equation, so we know that 4 then is going to be equal to 1/4 of minus 1 plus c. So now we can work out what c is. So 4 equals a negative 1/4 plus c. So take that negative 1/4 to the other side. So c is 4 1/4. So then our equation of our line is going to be y equals m, which is a quarter, x plus the y-intercept, which is 4 1/4. Advertisement break. Hopefully you are able to use this past paper to identify any topics that you still need to focus on for your exams. It's best if you do some focused revision around these topics between past papers, and this series of videos will help you do just that. They are based on the AQA topic tests, including key topics like trigonometry, surds, indices, and a whole lot more. Click on the card above to go to the playlist. I'm adding to this collection all of the time, so if the topic is you're looking for is not yet covered, it soon will be. So subscribe below to make sure you don't miss out on any of these uploads. Right, back to the maths. In question 28, we're told that the volume of a cone is 1/3 pi r squared h, where r is the radius and h is the perpendicular height. A cone has a horizontal base of radius 5, a height of 15, and the cone contains water to a depth of 9 centimeters. Work out the volume of the water. Okay, so basically we're trying to find the volume of that frustrum part at the bottom. Now a frustrum is made up of a cone with a cone taken off the top. So if we can work out the volume of the entire cone, this one, and then we can take away the volume of this smaller cone, we'll be left with the volume of the water. That's the plan. Okay, so a volume of the, should we do it in 3 parts? So the volume of the large cone is going to be 1/3 of pi r squared h. So 1/3 of pi r squared h, which is equal to, in this case, the big cone has got a radius of 5 and a height of 15. So that's going to be 1/3 of pi times 5 squared times 15. Okay, so I can divide the 3 into the 15. Let's move 5. And 5 squared is 25 times 5 is 125. So that means that the volume of the large cone then is going to be 125 lots of pi. Okay, so now let's do the smaller cone. Volume of small cone. Now the small cone is this green one up here. Now what we need to do is work out the radius and the height of this cone. Now the height's easy enough. It's the difference between the 9 centimeters and the 15 centimeters. In other words, it's got a height of 6. Now because the large cone and the smaller cone are similar, they have the same angles, etc., all their sides are going to be in the same ratio. So then the radius of the smaller cone is going to be 6/15 of the radius of the larger cone. Now 6 being the height of the small cone and 15 being the height of the larger cone. That's where the 6/15 comes from, and 5 is the radius of the larger cone. So our smaller cone has a radius of 6/15 of 5. So dividing that out, divide that 5 into that 15 gives me 3 and 1. 6 divided by 3 is 2. 2 times 1 is 1. So the radius of the small cone then is going to be 2. So volume of the smaller cone is 1/3 times pi times r squared times h, which is 1/3. We said the radius was 2. 2 squared, and the height is 6. Again, let's just simplify that out. 3 goes into 6 twice. So, oh, and don't forget the pi. I almost forgot the pi. Let's squeeze that in there. So 1/3 cancels with 6, leaving 2. 2 times 2 squared. 2 squared is 4 times 2 is 8. So basically the small cone has got a volume of 8 pi. Okay, so then the volume of the water is going to be volume of the large cone, take away the volume of the small cone, which is going to be 125 pi, take away 8 pi, which leaves us with 117 lots of pi. Just wanted to take a few seconds out to talk about my Patreon page, which you can find at patreon.com/Mr. Tompkins EdTech. On here you can gain access to exclusive content, including early access to my past paper walkthroughs. So if you like my content, definitely worth checking that out. Also, if you become a Pythagorean patron, you get a special shout out in every video. So check it out. Back to the maths. Okay, question 29. Horrible one to finish with. Simplify 2 sine 45 degrees minus tan 45 degrees divided by 4 tan 60 degrees. Give your answer in the form root a minus root b over c, where a, b and c are integers. So basically we need to recall our exact values for trig and do some surd simplifying to finish off with. So first thing is, do you remember your exact values for trig? Well, which ones do you need to know about? You need to know about values of theta for 0, for 30, for 45, for 60, and for 90 degrees for your 3 types of trig ratio. So sine theta, cos theta, tan theta. Now, the first and last are easy. The sine of 0 is 0, the sine of 90 is 1. Most people don't have too much trouble remembering that the sine of 30 is a half. So that leaves us the sine of 45 and 60 that we need to remember in surd form. 45 is root 2 over 2. And 60 is root 3 over 2. Now cosine's easy. Once you've written those down, the cosines are the same as the sines but backwards. So rather than having 0, half, root 2 over 2, root 3 over 2, 1, it's the other way around. So it's 1, root 3 over 2, root 2 over 2, a half, 0. And the tan is the first one divided by the second one. This is the sine theta divided by cos theta. So 0 divided by 1 is 0. Half divided by root 3 over 2 is 1 over root 3. 2 root 2 over 2 root 2 is 1. Root 3 over 2 divided by a half is root 3. And 1 divided by 0 is infinity. Okay, so they're all the values that we need to know. Now how you remember those is another video, but you need to remember all of them if you don't remember it the way I just did. Okay, so now we know what they all are. Let's sub them into this formula and find out what we've got. So 2 sine 45, that's equal then to 2 sine 45 is root 2 over 2 plus, sorry, minus tan 45. Tan 45 was 1, minus 1, divided by 4 tan 60. So divided by 4 tan 60, which is 4 root 3. Okay, so you notice here our denominator has to be a whole number, and at the moment we've got a surd down there. So we can simplify this a little bit. Well, let's multiply out the top part first. So they cancel, don't they? So it leaves me with root 2 minus 1 over 4 root 3. So to simplify the denominator, if we times top and bottom by root 3, root 3 divided by root 3 is 1. So multiplying through by 1 doesn't change it, but it will just change the form somewhat. Root 3 times root 3 is 3. So on the bottom, that changes to 4 times root 3 times root 3, which is 4 times 3, which is 12. On the top, I'm going to get root 2 times root 3, which is root 6, minus root, well, minus 1 times root 3 is minus root 3. So I'm going to get minus root 6 minus root 3 all over 12. So I think that is in the form that they want it to be. Yeah, got root 6 minus root 3 all over 12. So that actually wasn't as bad as I thought it was going to be. The key to it really is remembering this here. If you don't know these, you're a bit scuppered on these sorts of questions. So you need to find a way of remembering your exact trick values. Okay, I think we're done. Yep, paper over. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.